Well, hello from BitScope Designs. We have received our first Raspberry Pi 2. There's been a lot of excitement around the internet, as I'm sure you are aware. In fact, we've just been checking the latest blog post from Liz. Indicates they've been extremely busy too. We can see why. So here it is. This is the first Pi 2 we've got from our friends at Element 14. Let's have a look and see what we've got inside. I'm sure everyone else has done an unboxing video, but we'll just do a quick one here. And what have we got? Well, I must say, the king is dead. Long live the king. It looks pretty much identical to the Raspberry Pi Model B+. The Broadcom chip seems to be a little bit bigger. There's no RAM on top. Okay, there it is. So let's put this little guy through its paces. So we've now unpacked our Raspberry Pi 2 and we want to make a comparison with the Raspberry Pi Model B+. So we have mounted them together. You can see here, one on top of the other. You can see this is the B+, no RAM pack on the bottom. Interesting to note, just physically looking at them, you'd be hard pushed to tell them apart. This is of course what Evan has promised, and what James appears to have delivered in spades, with what is quite a beautiful PCB design. So let's see what this thing can do. So the first thing you'll need is software. If you pop down to the downloads page on Raspberry Pi, we're going to install Noobs Lite, which was uploaded just a couple of days ago. So we will download the zip file. Hopefully they'll have their website up for this okay. Yep, looks good. Whilst that's downloading, I'll just grab a copy of the checksum to make sure that what we get is what we expected. So we can see the download happening here, should be finished in a few seconds. Okay, let's see if we've got it. And we do. Let's see if it's what we wanted. Oh, hang on. I want to SHA some news. There it is. So we'll see if what we downloaded is what we expected. It is. Brilliant. We've got the package downloaded. Now let's unzip it. So we've got everything we need. Okay, now we've got the files on our disk. Let's put them on an SD card. We have a 16 gig Lexar SD card here. Let's plug it in. Okay, and open it. Okay, it's empty. Let's go to our downloads. Here we are. So let's select everything except the original zip and drag it across to the SD card. Here we are. Now we can unmount it. And the next step will be to put it in the Raspberry Pi 2 and start Noobs. Okay, so here we are with our Raspberry Pi. Let's get the SD card from our holder for programming, and we shall now put it into the Raspberry Pi itself. Simple. Next thing to do is to connect everything up. Okay, the first thing we want is a keyboard, which we've got a little USB dongle for that. We'll put in the HDMI cable, like so. And we can get Ethernet so we can talk to it. And last but not least, power. And see what happens. Have a look at our monitor up here. So the noobs installer is going through its usual thing. So far it looks the same whilst it initializes. Okay, so we will select Raspbian as the option for us, and we can then say install. That's fine. It's going to delete everything. Good. So we'll let that work its merry way. It takes a little while. We'll be back in a tick. So it looks like we're done. Successfully installed. Let's reboot and see what it does. So I won't go through all the options here. We'll just pick the defaults, as I'm sure you can read all the information from the Raspberry Pi website about how to do this. But the first thing we'll do is we'll expand the file system to be the full size of the card. Okay, and we won't bother changing password. Boot to desktop. Okay, we want to boot to the desktop. And no camera, no overclocked. Advanced options, what do we got here? Overscan, host name, that's already set, so we don't need to do that. Memory split. We will enable SSH because we want to be able to get into it. So now it's enabled, and I believe we're finished. Yes, we would like to reboot now. So here we are. Let's see if we get into our graphical desktop. Four Raspberry Pis, presumably one for each core. The beauty of the Pi 2, of course, is that it is an ARM7 architecture with 4 cores. We're hoping this provides quite a performance boost. And there we go. There's the new desktop, quite a bit cleaner than the old one. So here we are with the Raspberry Pi desktop, and we will download the BitScope software and install it to see if it will work. So open the web browser, visit BitScope, click the Raspberry Pi link, go to the downloads page and select the first option, BitScope DSO. Download it via this link here. There we go, it's downloaded. And now we need to do is install it. For that we'll go to the terminal. We'll go into the downloads folder. Oops. And there it is. Sudo dpackage-i bitscope.dso. Looks like it installed successfully. Now the next thing to do is to connect to BitScope. So I'll just have a look down here. Here's our Raspberry Pi, and here is a BitScope Micro with a snapboard attached, which will produce some waveforms for us. So let's plug that in, and good, we've got power as we expect. Now let's go back and see if we can run the software. We'll run it from the command line to start with. There it is. There's a few warnings there. but it seems to be running. There's BitScope DSO. First thing we'll do is see if it can see the BitScope. So we'll select USB, and there's only one. That must be the one. Click OK, and then power it on. This is development edition, so we'll click through, and then give it 3, 4, 5, 6, some more seconds to load up, and it's running. So there's BitScope DSO. If we have a look at the BitScope itself, we can see that it's flashing, doing its stuff. Let's see if we can get a waveform up. In this case, what we have to do is select the waveform generator to power on the little board we've got attached. And there it is. It's not triggering, so let's put it on mean, and we'll set the trigger across to mean triggering. Okay, there we go. We now have a sawtooth waveform being captured by the BitScope running on a Raspberry Pi 2. We can see, here it is, flickering away. Now let's see if we can actually see the full suite of signals that this little board can generate. So we'll go into mix mode. We will set the offset to mean. There it is. Brilliant. It appears to be working. Well, that's simple, particularly considering the software is actually the bog standard binaries that we built for the original Raspberry Pi. So true to Eben's word, it just runs on the new one.